Now, to do the other balance of the problem, it's momentum balance, right? Conservation of momentum. We have the mass of the bullet, the big mass of the block. So the mass of the bullet times the velocity of the bullet is going to be equal to the mass plus the mass of the bullet times this v that you get from over here. That's going to give you the two equations that link together. This is the conservation of momentum, and this is going to be the equation that gives you the energy, the velocity that you go there. Okay, any question on chapter 11? 3 problems, okay? It should be straightforward, okay? Are we good?
I'm going to get the notes from.
Yes? Okay. All right. Now let's go on to the next chapter. The next chapter is our simple harmonic motion chapter. So chapter 12 is on SHM, simple harmonic motion. Okay, so to do these problems, we first looked at in this chapter we have a spring that has a spring constant K, and we have a block of mass M hung on the spring. This spring, when you touch it, it's going to bob up and down at its natural frequency, okay? But we have a formula that gives you us the period of that oscillation. The period is going to be equal to 2 pi times the square root of M divided by K, okay? So you take the mass here, plug it in here, divide by the spring constant here, take the square root of that, multiply by 2 pi, and you have the period. Okay? If I want to know what the frequency is going to be 1 over the period. So you just reciprocal that, and you can get the frequency. Yes? Now, we also talked in chapter 12, we talked about another object that does simple harmonic motion, and that is going to be a pendulum, yes? And we have a simple formula, T equals to 2 pi times the square root of L divided by G. Okay, so once again, you should be able to figure out the period of the pendulum by getting the length here, and the gravitation is G 9.8, and you should be able to get the period. Yes? Mm-hmm. Now, in this chapter also, we talked about, and I believe it's still in the same chapter, but I think this is a 4-chapter section unit or chapter section. So we went into the property of waves. Yes? So we have this, that the velocity of any wave is a product of the frequency times its wavelength lambda. Okay? So real simple problem. You might be able to have to calculate the frequency. If I give you the wavelength and the velocity of the wave, you should be able to plug it right in and go boom and tell me what it is, right? Okay? The final problem in this chapter is going to be you have to analyze a wave like this, okay? You're going to have a chart of a wave. So when we have a sine wave like this, it goes up and down like this, the height from the baseline here to the top here, that is going to be called the amplitude. Okay, so you should be able to get that and read that. And some of you guys get things backwards, okay? The next thing you would want to be able to calculate or be able to look on this graph and figure out is going to be what is the wavelength, because when you go, this axis is going to be like in centimeters maybe, and then where the wave goes from here to another repeated spot. See how this is one cycle. The distance from here to here is the wavelength lambda that would go into this formula, yeah? Now, if I give you the velocity of the wave, which would go here, you should be able to tell me the frequency, and you should be able to tell me the period, because we've already had the formula, it's 1 over the frequency, right? So you should be able to get all these wave properties for this wave, yeah? All right? Now, any question from, for chapter 12? We good? Okay, so on this test, if you're doing good so far, we're up to problem, we're gonna be in problem 8.